Hey everybody, it's Mr. Allred from Calculus class, and we're still talking about optimization. So here's a problem. It says an open top box with a square bottom and rectangular sides is to have a volume of 256 cubic inches. Find the dimensions that require the minimum amount of material. So let's just kind of write down the things that we know from this problem. What we know is we have a box, okay, and it says it's open top. Let's see here. It has a volume equal to 256 cubic inches. It has a square bottom. And what it says here is to find the minimum amount of material. So we know that if we had this box and we filled it up with water, it would hold 256 cubic inches of water. I guess that's a lot, not sure. But what we're talking about here is we're given a volume and we're asked to use the minimum amount of material to make the box. Well, when we make the box and we put sides on it in the bottom, what we're trying to do is we're trying to minimize surface area, because the surface area is the amount of material it would take to build this box. Now, I'm not good at drawing, so let's see if I can, got something ready here, and there's the box. So I'm not sure how well that looks to you or how good that looks to you. Let's kind of make it a little bit bigger. Just don't tilt it like that. But I tried drawing the box earlier. It didn't come out too well. But here's our box. So what we see here is we've got the square, we've got the square bottom with X and X, and right now we have a height. Okay, and I don't think we really want to use that height, because while we're trying to do a surface area, and let's just call it S, we know the surface area would be the area of the bottom, which is X squared. It has no top, so we don't have the extra X squared up there. And all the sides are XH, and there's 4 of them. So there's 4 sides around the box and the bottom, and no top. So that's all 5 sides. Now from the surface area, we're going to want to take the derivative and set it equal to 0. That's what the minimum is telling us. Okay, so derivative equals 0. Okay, that's what we think of when we see that word minimum here. But we don't want both the X and the H in there. So we're given some information about the volume. So maybe we can replace the X for the H, and the H looks like the easier one to replace. So I'm going to come over to the side and say volume equals, and looking at this picture, it would be X times X for the base, X squared times H. So that is length times width, which are both X, and the height, which is H. That volume was 256. So if I want to replace the height, I can come over here and I can divide it out. 256 over X squared. Let's see what happens. We'll just take that and we'll plug it in for H over here. So right now we're saying H is 256 over X squared. So let's come to our surface area formula. X squared plus 4X times 256 over X squared. Now I know I'm going to have to take the derivative of this, so I'm going to clean it up a little bit. But let's slide this up so we have a little bit more room. It's not sliding. There we go. So I'm going to clean up my surface area formula. S equals x squared plus 256 times 4. Let's find out. I've got my calculator. I don't like making too many mistakes. 4 times 256 is 1024. And then I've got x over x squared, so that'd be a single x on the bottom. But if I'm going to take a derivative, I'm going to bring it up as x to the negative 1. I prefer negative exponents when taking derivatives to denominators. So let's go ahead. Take our derivative, s prime, for our change in surface area, will be 2x, using the power rule here, minus 1024 times x to the negative 2. And I'm going to do two things here. I'm going to set that equal to 0, and I'm going to rearrange it a little bit. So 0 equals 2x minus 1024 over x squared. So to kind of keep the problem on the same page, let's just pull it over to the side. So let's rewrite it again. And I like to teach that if you have a denominator in a equation, I like to multiply through by the denominators to get rid of them. So I'm going to multiply everything in this equation by x squared. That's something I'm introducing. Okay. So if I do that, of course, well, let me make it clearer just in case you do a different problem. But x squared times 0 is still 0. 2x times x squared is 2x cubed. And 1024 over x squared times x squared is just 1024. So that's a minus 1024. So I have an equation set equal to 0 here. I know I can pull a 2 out. So I have 0 equals 2 times x cubed minus 512. Let's see. I'm going to pick up my calculator and see if I set this x cubed minus 512 equals 0, x cubed equals 512. Let's see if there's a cube root of 512. 512. So this would be 2 1/3. Yes, it is 8. And in our case, that would represent 8 inches. So that cube root of 512 would be 8. So what we're looking at is the base is 8 inches by 8 inches. And I can come up here and find the height because I had an equation where x was related to h up here. So 256 over x squared give me h. So let me see. That would be, if I want to write it out, 256 over 8 squared, which would be 64. I'm going to guess that that's 4. Let's see. It is 4, and that is h. So the height is 4 inches. So the dimensions are 8 by 8 by 4. Now it's kind of important that the 4 is the height because remember it was a square bottom and no top. So it can't we can't turn this to the side or flip it around or something because that would mess up the dimensions. So if we made the bottom 8 by 4 and didn't put a top on it, it would be all wrong. We'd still have the same volume, but we wouldn't be using this least amount of material. So let's just check. If I brought it back over, and this is not part of the question, but let's, excuse me there. Let's kind of come in the middle here. The surface area would be 8 squared, that would be the bottom, plus 4 times, that's the 4 sides, 8 times 4 for the length times the height. So that surface area would be 64 plus 32 times 4, 128. So the amount of material it would take to make this box, or the minimum amount of material it would take to make this box, would be 192 inches squared. So if we had that much material, we can make this open top box with a square bottom that would hold 256 inches cubed. Okay. So key things here were that we were given information about a volume, which we could use to link over to the surface area. So they had a definite link in this problem, so that we had it in one variable, take the derivative, set it equal to 0, so that we can find the minimum in this case. All right. Thank you.